Hello. Let us now write the insert at head operation. The function is similar to the insert at tail. The only difference is that it's going to add a new node at the beginning of the linked list. So we will update the head pointer instead of the tail pointer as we did in case of insert at tail. I'll just copy the code that I have already written there under insert at tail and we'll update that accordingly. So let me copy that. Okay, here we go. Now the portion that deals with creation of new node and assigning the data to the data field of the new node remains same. Now handling the situation when the linked list is empty also remains same, because this is the node that is the only node that we are going to add there in the linked list. So both head and tail pointer is going to point this new node. So updating the head and tail there. Otherwise, if the linked list is not empty, that's this else part, this portion has to be updated. So in this case, the next field of this new node should point to the current first node. The new node pointer is new node ptr arrow next. This should be assigned with the current first node's address, and that we can get from the head pointer because the head pointer always points to the first node. So list ptr arrow head. So the next field of this current node is now pointing to the first node. Now we need to update this head with this new node's address. So list ptr arrow head equals new node ptr, and we are done. We need to increment the node count as well because we are adding a new node there at the beginning of the linked list. So node count must be incremented by 1. The best way to understand a function is to dry run that function. Just take your pen and paper and draw the images and put the numbers there and execute each statement as it is there in the function and see how that function works. Let me show you how we can do that. I'll dry run this insert at head and I'll show you how to do that. Here we go. Say this is our list object and that contains a head. Initially that is null. I'm guessing that the linked list is empty. And also we have a tail that is also null. And we have a node count there that is 0. Now let us consider that the address of this object is 500. And we are passing that address here in the list pointer. So the list pointer is going to contain this 500 there. And this list pointer is pointing to this list object. So list pointer arrow head is this head and list pointer arrow tail is this tail. Let us consider that this data is 10 that you are going to insert into the linked list in a new node. So when we are here in the function, the first statement is the malloc function call that's going to create a new node there. So let us consider that this is the new node that is created by malloc and that is at address 1000. All these addresses that I am using, this 500 and 1000, they are actually abstract in sense. Practically these addresses will be something different. I'm just using these numbers to make you understand. So this is the new node pointer. That's the pointer to this node that the malloc created, and this new node pointer contains 1000. That's the address to this new node. So this new node ptr is pointing to this node, and the node contains two sections. First one is data and second one is next. That's a pointer to the next node. So now new node is null, new node pointer is null. No, that is not null, that is 1000. So we are not going to enter here. Here we come at line number 104. Now new node ptr arrow data, that means we are accessing this data field within the new node and we are assigning 10 that is contained in this parameter to that data field. So 10 is assigned there. Let me use a different color. Okay, so 10 is assigned here. Now we are assigning null to the next field in the very next statement. As you can see that there at line number 105. So here we are assigning null. Now we are checking if the list pointer arrow node count is 0. That means if the linked list is empty or not. Yes, indeed, list ptr arrow node count means we are accessing this node count actually, and that is 0 indeed. So this if is going to be executed now. Now, first of all, what we are doing, we are assigning the address of this new node to the head pointer. You can see that list ptr arrow head. That means list ptr arrow head means this one, this head. So we are assigning the content of new node ptr, that is 1000, to here in this head. So here we go. Instead of null, now this head is going to contain 1000, and head will be pointing to this now, the new node. And then in the next statement, we are again assigning this address to the tail pointer as well, because tail will also point to this node. So here it is. We are assigning 1000 again here, and this tail is also pointing to this. So both head and tail are pointing to this new node. That's the first node, that's the last node. And then we are not going to the else part because if is satisfied, and we have executed the if. So here at line number 118, we are incrementing the node count in the list object. So instead of 0, it will now be 1. So that's it. We have added that new node with the linked list. That's the first node, that's the last node, that's the only node there in the linked list. So when the linked list is empty, this is the way that the function works. Now I'll consider the case when the linked list is not empty. Okay, let us now consider the situation when the linked list is not empty. That means there are nodes in the linked list, and we have called this insert at head operation to add a new node there as the first node. So here you go. You can see that we have this list object there at address 500, and the list pointer that receives this address in the function. So this pointer contains 500 there and pointing to this list object. The list object is declared in the main function. Okay, and the first node of this linked list is right now 1000, and the second node is at address 2000, and the third is at address 3000. So the head pointer is pointing to the first node. So the content of the head pointer is 1000, that's the address of the first node, and the content of the tail pointer is 3000, that is the address of the last node. And the node count, it must be 3 instead of 2. Okay, let me just delete that. So the node count is right now 3 because there are 3 nodes in the linked list. Now we have called this function insert at head, say with the content, with the data 40. So this is the data that we need to add as the first node. Creating the new node there with the statement at line number 99. Again, the malloc has been called. So let us consider a new node has been created successfully. So here we go. This is the new node. Say the malloc has created this at address, say 4000. And within this, we need to assign the data. So here at line 104, we are assigning data 40 to this data field of the node. Now this 4000 is there in the new node pointer. You see that this new node pointer is going to contain, let me write it there, new node ptr, that's the pointer to this node, and that contains this 4000. That's the address of this newly created node by malloc. So we are using this new node ptr arrow data to access this data field of the new node, and we are assigning that 40 to this data field. And the next is null at the beginning. Okay. Now, is the node count 0? No, it is not. You can see that list ptr arrow node count, that's 3. That's not 0 there. So it comes to the else part, and new node ptr arrow next. Now this is important. New node ptr arrow next means this portion. This is the next field of the new node, and we are accessing this. And we are assigning the content of the current head, that is 1000, right? So list ptr arrow head is 1000. That is the address of the first node, right? Current first node, and that is 1000. We are assigning this 1000 here in the next pointer field of the new node. So here we go. Copy that 1000 here. So this next pointer field is now pointing to this current first node. Because this new node ptr, because this object pointed by new node ptr is going to become our first node. So the current first node is going to become the second node. So the next field of the new node has to point this current first node. And then we are updating the head pointer there at line number 116. So list ptr arrowhead, list ptr is 500, arrowhead is this, that means this content. So it is updated with the content of new node ptr, and new node ptr is the address of the newly created node, that's 4000. So let me update that. So here you go, 4000 is copied here. So now instead of pointing this 1000, this head is going to point 4000 location. That means the new node. So you can see that the new node has been added with the linked list now. Is added as the first node. So that's how the function works when the linked list is not empty, to add a new node as the first node of the linked list. I hope you have enjoyed this, and I'll recommend you to just try and the algorithm some more times with your pen and paper, and you'll enjoy to do that. Thank you very much.